All right, so today we start looking at covalent bonding. So we're saying that covalent bonding, this is the bonding that exists between non-metals. It is the sharing of electrons between non-metals to achieve the structure of the noble gases configuration. Noble gases are stable. Why are they stable? Because they have got what you call full structure. If you check on your periodic table there, when you are writing the electronic configuration, you'll find that those ones, they're very stable. They have got 8 electrons in their outermost shell. So for any element to be stable, meaning that it can either have 2 electrons in its outermost shell, and then or it can have 8 electrons in its outermost shell. So when you look at chlorine here, chlorine, we're writing a dot and a cross. So we're saying that they share. How do they share? It means that chlorine will share what it needs, and also the other chlorine also will share what it needs, like that. So now when you look at this one here, there is Cl2. That means that there is Cl2 means that there are 2 chlorines there that were bonded together. Now when you look at the periodic table. When you go to a periodic table there, you are going to check the number panza also. When you check the number down there, you're going to find that that number is 17. And there's also another number 17 there. When you write the electron configuration of chlorine, the first shell has got 2 electrons, then followed by 8, followed by 7. It's the same as this one here, 2,8,7. That means that for chlorine to be stable, it needs 1 electron. It needs to gain 1 electron for it to have what? 8. This also chlorine needs to gain to have what? 8. That means that this chlorine will share what it needs. This one needs 1, so it will share 1. This one also needs 1, it will also share 1. So now, what happens is that we're going to draw 2 circles and another circle here. This is for Cl, Cl. I'm just showing the last shell there. So this chlorine will share X, what it needs. This one also share a dot there. After sharing, what will happen? There's 1, 2 here, 1, 2 also here. That means that we're remaining with how many? We're remaining with 6. So we're going to have 1, 2, again 1, 2, again 1, 2. So again we're going to have 1, 2, again 1, 2, again 1, 2. That means that we're going to have 1, 2 here, 3, 4, 5, 6, 7, 8. Again 1, 2, 3, 4, 5, 6, 7, 8. This is the bonding in chlorine. So that means that chlorine at that moment it is stable because yakwana yali 8. When you look at even hydrogen there, when you look at hydrogen there, we're doing the same thing again. We're doing the same thing that we did. When you look at hydrogen there, when you look at hydrogen there, also hydrogen, okay, also hydrogen here, it's H2. So it's H2. That means that it is H-H. When you look at the periodic table down there, hydrogen has got 1. So even this one has got 1. So for it to be stable, it needs to gain 1. So it will need to gain 1, and also this one needs to gain 1. They are the same, but I'm just differentiating them with X and a dot. So when we draw, we're going to draw 1 here, then the other one there. So this is H and this is H. This one will share what it needs, a dot. This one also share a X. This one also share a dot. It is stable. So 1, 2 here, 1, 2 here. We're not going to have anything outside because hydrogen has got only 1. It only needs 1 so that it becomes 2. So then that is our bonding. Coming to the other one there is the carbon dioxide there. So in carbon dioxide there, it's CO2. When you look at CO2, that means that you cannot write C, then CO2, you cannot write it as COO. No, these are atoms of the same element. Then this one is different. So when they are bonding, you're going to write as in O, C, then O, like that. Now you look at oxygen. Oxygen here, when you look at the periodic table, it is in group 6. It has got 8. This one has got 6. This one has got 8. When you write the electronic configuration, the first shell has got 2 electrons, how many are remaining? 6. Then this one is 2,4. Then this one is 2,6. That means that how many electrons How many electrons does this oxygen need to gain to become stable? It needs 2, so that it becomes what? 8. So I'll write 1, 2. How many does this carbon need to become stable? It needs what? 4. So that 4 plus that 4 that it needs, it becomes what? 8. So we're going to have 1, 2, 3, 4. This one also needs 2. So when I draw, I'm going to draw 1, 2, and also 3. So this is OCO. Then we start sharing. This one will share X there. This one will share a dot there. This one will share X there. This one will share a dot there. We are done sharing it. It means that we have already shared these 2 and these 2 here. We go the other side again. Again, this one will share X. This one will share a dot. This one will share the X. Then this one will share a dot. Then it means that we're done. That is how the bonding is going to end. Then that means that we're going to have 1, 2, 3, 4, 5, 6, 7, 8. For carbon. But 1, 2, 3, 4 for this one here. We remain with it. We need how many? 8. This one represents the last shell. So it means that we're going to need 4. So we're going to have 1, 2, and 1, 2. Again, we're going to have 1, 2, and 1, 2. So that means that this is the whole bonding. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It is done. That is how you write the bonding in oxygen. Coming to ammonia down there, okay? For ammonia, we have NH3. That means that you have got N, H, and another H there. So when you look at nitrogen, when you look at the periodic table there, nitrogen has got 7. So the electron configuration is 2,5. So how many electrons does nitrogen need to get to become stable? From 5 to 8, how many are missing? 3 of them. So that means that we're going to have 3 of them. They are 1, 2, 3. But this hydrogen, how many does it need? The same as this hydrogen here. It needs only 1. This one only needs 1. This one only needs 1. So when you draw it like this. You draw 1, you draw 1 there, 1 in top, and the other one side here. Then we have N here, we have H, H, H. If you wanted, this could have been drawn down here. So, okay, let me just do this. Let me remove it here if you want. Okay, we're going to have 1 here, which is hydrogen. Now, what happens there? We start sharing. This 1 will be shared with this one here. So we're going to have a dot. Again, this one will be shared with this one. We're going to have a dot. Okay. Then this remaining one will be shared with the remaining one. So we're going to have a dot like this. So we have 1, 2, 3, 4, 5, 6. But we're supposed to have how many? 8. So 6, 7, 8, like that. But this 1, 2, like 1. 1, 2, like 1, like 1. Just like that. That is how the bonding for that comes out. Then the last one there, we have methane. When you look at methane there, it is CH4. So CH4, we're going to have C, then H there, H there, H there, and another H there. According to carbon we said needs how many? 4. 1, 2, 3, 4. But this one needs 1, this one needs 1, this one needs 1, and this one needs 1. So when it comes to drawing, we're going to draw 1 here, and then we're going to draw 1, 2, 3, 4. So this is carbon, hydrogen, 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 and hydrogen. That means that now we start sharing. That means that this one here is shared with this one. So we are going to have a dot. This one is shared with this one. We have a dot. This one will be shared with this one. We have X dot. The remaining one will be shared with that one. We have X dot. So it means that 1, 2, 3, 4, 5, 6, 7, 8 for carbon, 1, 2 for hydrogen, 1, 2 for hydrogen, 1, 2 for hydrogen, 1, 2 for hydrogen. This is the bonding. Covalent bonding is very important because it comes during the final exam. So, but that is how you are. So there is exercise down there for oxygen. So this is one that I want. I want you people to draw for this one: oxygen, hydrogen chloride, nitrogen, ethane, and then ethane. I want you to draw those ones and you send them to me.